Were you able to access the video? Were you able to access the video from the lecture? By the way, I posted two videos, two lecture videos there. Were you folks able to access it? Yes. Okay. Good. Anybody else? Those videos, you know, they, when you save that on the computer, you know, it occupies lots of space in the computer. So I avoid recording them because my computer is already running out of disk space here. And then I still have to upload them to the cloud. So here you go, false by. Okay, I have to change this one here and 0, 5 dash. That's gonna be P06. P06 lab notes fall 2022. But like I said, you know, most videos that I posted in there, they're not edited, so I would say they're not very good quality. So it requires a lot of patience on your side to understand them. Remember, they're not edited. Okay. Whenever you prepare a video, ideally you should be editing it. It takes quite some time to do that. Why do we edit it? We edit to condense the information as much as you can. So there's no blank spaces in between, right? So most of the videos are not edited. Most of the videos that posting there, but some of the videos, especially the lab videos, I have lab videos in there like 20 or 30 minutes long that I managed to compress them in a very short, you know, in a relatively short time period. Lab notes, good. So here we go. Now, one more student coming here. Okay. Today it's 14th of September, 2022. Okay, I covered that already, right? The basic quantities of physics. And the primary definitions, the law of physics, so I can delete that part here. Oh, yeah. Here you go. Let me, what I'm going to do, I'm going to start talking about significant figures. Okay? And this part here, we also have to continue talking about the graphs. I didn't upload your data yet for today's lab, but we're going to get there. Let me put this thing a little bit below here. Okay, and here you go. I'm going to put that right here. So let's go back to the graphs that we were working before, right? At this point in time, you should have this graph here that we did last week in the last lab. Everybody has that? Let's start with this graph. Okay, we are going to continue practicing the graph. I want you to understand what those statistical parameters means, okay? So here you go. I plot a graph that has a perfect correlation, okay? That's what we call a perfect correlation. Perfect correlation means what? The R square is exactly equal to 1, okay? Remember that? The correlation coefficient is exactly equal to 1. So continue with our notes. By the way, do you see my screen share, the screen that I'm sharing here, the graph that I'm sharing? Please confirm that with me. Yeah, okay, good, thank you. So I'm gonna write that down here, lab notes. We're gonna get to the, so in this lab, what am I gonna do in this lab? First, in this lab, first, we will continue with the graph plot we started last week. So whatever we do here is going to be slightly different from whatever I did before, right? So I'm going to be making some little editing in my notes. Okay. So the graph plot we started last week. Okay. At this point in time, you should know the following. You should know the following. One, how to build a table of data in Excel. Okay. It's rather straightforward, right? Here you go. Here's the table. Here's the table. Okay. X and Y values. Here's the values that goes along the x-axis, and here's the values that go along the y-axis in your graph, right? Here you go. X-axis. I'm gonna write it down. X-axis, so there is no confusion. Y-axis, right? That's how Excel treats data by default. That's how Excel treats tables by default. You can change this default, right? There's a way to change this default, but consider that the default way of plotting graphs. Okay, so you should know how to do that by now. Oh, this one right here. How to build a table of data in Excel. 2, how to plot your data in a graph using Excel. Okay, all those videos that are in my YouTube channel, they explain that as well. There you go. How to plot your data in a graph using Excel. And we did that as well. You know, what else you have to know? You have how to prepare your graph to display the parameters along the, let's see, not how to prepare your graph, how to label, here you go, how to label the axis of your graph. Right? To label the axis of your graph. We did that as well. Next, how to obtain the trend line of your graph. Oh, there's one more here that I didn't do it. How to adjust, right? The units. Let's see this. Yeah, the units along the axis, right? The axis. We did that as well. We don't want the units too close to each other or too far away from one another, right? Here they are separated by 1 second along the x-axis, right? Here they are separated by 1 meter along the y-axis. What else? Here you go. How to obtain the trend line of your graph. Okay. And we stopped writing here. How to display, right, the trend line of your graph, and how to display the R-square value of your graph, the statistical parameter that tells you how close. Okay, remember this R-square is a measure. So what's R-square? R-square is a measure of how close your model, your mathematical model. Mathematical model. What do I mean by mathematical model? The mathematical model is the regression equation, right? Regression equation. And I should correct here as well, right? How to display the regression equation slash the trend line slash regression equation of your graph. R squared is a matter of how close your mathematical model, the regression equation, is to real life. Real life. And what's real life? Your actual data that you collected during the lab, collected during your lab. Okay. So prediction versus real life. Okay. That's what the mathematical model is all about. Your mathematical model is your prediction. Mathematical model is your prediction of how this data behaves. Okay. Your data, your experimental data is, a quantitative measure, right? Quantitative measure of real life. That's how I like to picture what we're doing here. You go to the lab, you collect data, you collect mathematical data, you put in a table, okay? Your experimental data, you collect the numerical data, right? Your numerical data is a measure of real life. And then you process this data by creating a mathematical model, which is the regression equation. Your regression equation can be used as a mathematical prediction for what the data is doing. Okay? So that's what you should know. Now let's play a little bit more with this graph. That was just a summary of what we did last time. Okay? This is just a summary of what we did last time. Let's play a little bit more with your data, and I want you to follow with me, okay? Like I said, real life data, going back here. In general, you will rarely get an R square that is equal to 1. Okay? R square equal to 1. Equal to 1 means that you have perfect match between your mathematical model. Yeah, and again, what's mathematical model? Your regression equation, right? And your data. That's what R squared equal to 1 means in your data. And R squared equal to 0 means that you have no correlation whatsoever between your mathematical model and your data. That's what it means. Okay. That's what you need. And then you have everything else in between, right? And then you have everything else in between. You have everything else in between. Anywhere between 0 to 1, you're going to get a, you're going to get a value for your R squared. In those experiments that I perform in the lab, we usually get R squared that are very close to 1, 0.9, 0.95, depends on the experiment too, right? And then also depends on the skill, the experimental skill of the students, if they perform the experiment properly. And also, it depends also if the equipment is working well, okay? Then you have everything else in between. Let me give you an example of what we usually get in a lab for the R squared. Okay, you're not going to get anything like that in the lab. Okay, you're actually going to get something more like the following. Here instead of 0, you're going to get, let's say, 0.05. Okay, and here instead of 1, you're going to get, let's say, 0.95. Okay. Here instead of 2, you get, let's say, 2.2. 2.2 is, do you see how the data points are moving away from the regression line? That's what you usually get when you go to the lab. Okay, you still have a regression line that's pretty much of a straight line. It also is very close to y equal to x, but it's not exactly close. It's not exactly y equal to x, okay? And look at your R square. What happens to your R square? It decreased from 1 to 0.9987. Okay, so let's continue here. You know, let's say I'm going to exaggerate in this one now. I'm going to put what? I'm going to put 3. Let's see, I'm going to put 2.5. Okay, this one's kind of behaving like a kind of an outlier. We call that an outlier in statistics. It's very, you know, is pretty far away from the line, from the regression line. Outliers, have you heard that? Outliers in statistics. Okay, so, and then what's next? This one, I'm gonna put a little bit close, okay? Let's see, this one I'm gonna put a little bit far away, here you go. And this one, let's put 5.5, okay? That's how the data you get is gonna look like. It's still R square equal, it's not R square equal to 1, but it's very close to it. It's not, the regression line is not y equal to x, but it's pretty close to it. Look at the slope here. It's 5% off of 1, okay? And you have a slope here, right? And you have an intercept. That's also very close to 0, okay? That's the type of data that you're going to get in real life. R squared that's less than 1, a regression equation that is still a linear equation, okay? But not exactly what we had before, right? When we had an exact correlation, okay? So now we have, that's the type of data you're gonna get. Okay, and today you're gonna get a set of data to see exactly that we're seeing. Okay, what else you have to know? Okay, there is this measure here of R squared that tells you how close your data is to the regression equation. Okay, so let's type it here and let's document this one here, lab notes. Else in between, okay? So in today's class, right? In your Google Doc, yes, I can do that. Yeah, let me save that. But remember, you have to learn how to do that, right? You have to learn how to plot those things. And I don't have the steps, right? That I went from one graph to another one. Okay, I don't have the steps that show me going from one graph to another one. Let's see here. Put that. Yeah, save. And I'm gonna go to my code, not this one, is it? Okay, that's not this folder, is going to be this folder. Let's see, this one, graph Prati. Okay, and where is, I'm gonna get out of my YouTube channel here. I'm working with a single screen here, folks. I hate working with a single screen because it's very difficult at times to navigate in a single monitor, in a single computer screen, right? I'm gonna get my second screen very soon. Let's see if I can get it. Okay, good. That's what I want. You know, whenever you have 2 or 3 screens, monitors, right? Computer monitors, very much easier to organize things. Here you go, Google Drive, sign in. 2022 fall folder, physics 6 shareable folder. Okay, I'm gonna upload this graph there, but don't forget, you know, you have to know how to do that. And at the end of this course, you know, you're gonna become an expert of plotting graphs. Okay, we're gonna plot so many graphs during the semester. that you're gonna become an expert on how to do that. Graph Practice. If you want to download it, yeah. What else do we need? Let me get something else here for you that you are going to need in the next step. I have to go to my Spring here, P07, shareable folder. You know, I'm reusing, not this one either. Let's see. Okay, that's not the one. It's not here. Let me see if it's here. Oh. Is it? Let's see. Sure, it's supposed to be here, but I can't find it now. Let's see here. 38 notes. Must be, let me see, in my 2021. Bear with me, please. Oh, shareable folder. Oh. Strange, not here. 37 notes. Oh, folders, folder, Spring. Folder, document. Oh yeah, here you go. That's the one. I do not know what it's doing there. Move. Okay. Should be moving. That's the one I want. Then now we are going to start talking about the confidence level, which is another measure of a better measure of how close your data is to your regression equation. Okay. Spring 2022. Here you go. Fall. Physics 6. Shareable folder. Right in here. Now you have it. Go ahead. Download this file. You're going to need that for the rest of the semester as well. Okay. Fall Physics 6 shareable folder. Okay. Confidence. So now you have two more documents that you're going to need. Okay. The graph Practice and this confidence level table. I'm going to download it. Okay, and here is the table, how it looks like. You will need to learn how this whole thing, how this whole table can be used to your advantage to quantify how close, in a better way, quantify in a better way how close your data is to your regression equation, okay?
Professor, I have a question.
Yeah.
When we do our lab assignments and we submit it to you, first off, where do we submit it? And when we submit it, do you want it to be an Excel sheet or Excel PDF?
Okay, yeah, it's going to be in Excel, in the Excel sheet that I'm going to provide to you. We're going to get there. And where do you submit your graphs? Where do you submit your lab report, right? You're going to submit your lab report on your group folder. Okay, if you're group 1, you upload your Excel sheet, okay? And also there is a Word document there, right? That I'm going to cover with more detail to your group folder, okay? We're going to get there.
Thank
Make
you
sense?
so much.
Okay.
Yes, thank you.
Yes, sir.
Yeah.
Yeah. So I understand we need to get the Wiley Plus to access the book. Do you know if it's possible if the 9th edition is the same as the 12th edition? Because I'm able to get that.
Let's see. Don't forget, you're telling me that you have the 9th edition book in physical format. Is that right?
Yeah, I have the PDF of it. I can
you
download
have-
the PDF. So I'd rather do that, you know, instead than getting the Wiley Plus if the only thing accessible is the book.
Okay. Okay. Yeah, it's okay to use the 9th edition of the book. Yes, it's okay. We're talking about the lecture now, right? Now, don't forget, you need Wiley Plus to do the homework, right? You need Wiley, and if you have access to Wiley Plus, you're gonna automatically have access to the ebook that's online. Okay.
Yeah, but would it be possible to submit assignments without having the book? You know, I'd rather just use the 9th edition and, you know, not pay extra just to submit lab assignments. Would it be possible if I could do it maybe over Canvas? Like you could open it for both Canvas and both Wiley Plus, so it's easier.
Let's talk about that during my office hours, okay? And let's see what we can do about that, okay? So here you go. Now, let's go back to my notes here, right? So in addition, okay, in addition to the R square, okay, we also have another statistical parameter that is called the confidence level. Confidence level. Okay. The confidence level, I also call it CL. The CL is a better measure of the closeness of your data to your equation, to your regression equation. Regression equation. The CL is a better measure of the closeness, right? How close is a better measure of how close your data is you know, not how close your data is, but it's all the way around, right? How close your regression equation is. Your regression equation is to your data. It's all the way around, right? The R square gives you an idea of how close it is, but the CL is a better measure. Okay. You know, and how is that? The CL is a function of the R square. Yeah, it is a function of the R square, but it is also a function of the number of data points that you have in your graph. It's a mathematical relation, okay? And this mathematical relation is not simple, it's very difficult. That's why we use that table that I provide to you in the, that's why I use, here you go, in the shareable folder. Okay, so here you go, here's the table. Here's the table. Let's read this table very carefully. Let's become familiar with this table. Okay, critical values of R square for different confidence levels, for different CLs. Okay, so I need you to look very closely at this table and understand what's going on. Okay, and I'm going to display this table here in a very, in my spreadsheet. Here you go. What do we have first? We have N at the extreme left, right? And N start at 3. 3, 4, 5, 6, 7. What's N again? N is what? N is the number of data points in your graph. Okay, here is your graph, right? Oh, here's your graph, right? How many data points do you have here? How many data points do you have here? That's a quick question. Go ahead, answer me. There's someone else trying to come in. Think about that. How many data points N do you have here? Gotta count them in your graph. Can I hear from you in the chat box? Yes, yes. Someone said 6, someone said 7, right? You gotta count the number of data points, right? Notice that the first data point starts with 0, but I still consider a data point. So from here to here, we have 6. If we consider the 0, you're gonna have 7, okay? Just the way the data was displayed there. So n in this case should be 7, okay? I'm gonna label this spreadsheet here, confidence level, okay? That the very first value that we have on the table. You don't have to worry about this one, okay? You don't have to worry about that's called the degrees of freedom. Notice that the degrees of freedom is n minus 2, right? If n is 3, degrees of freedom is 1. N is 4, degrees of freedom is 2, and so on, okay? And what else do we have here? We have CL, okay? CL along this horizontal line. So if I were to plot that in my spreadsheet again, okay, I'll put it CL here. My table has a CL, it's just like something, CL has similar values to R squared, okay? The confidence level is measured in terms of percentage. Here you go. CL is anywhere between 0 and 1, just like your R squared. 0 and 1. Even better, can be equal, greater or equal than 0. You can also say that the CL, goes from 0% to 100%, right? And that's what 100% is all about, and that's what 0% is all about. The numerical value 0, numerical value 1. Okay. The higher your confidence level, the closer. Here you go. Now, just like R squared, here you go. The higher the CL, the closer your regression equation is to your set of data points. But like I said, CL is a much better measure of this closeness. Okay? A much better measure of this closeness. And we use the table to find out what's the value of your CL for given values of R squared and N, right? So let's go continue. Okay, CL, what we have there in my table, I have 0.95, 0.99, 0.999, and so on, right? If you take a look at that, even better, I'm gonna put in a different way, 1 minus 10 to minus 1, 1 minus 10 to minus 2. Yeah, 1 minus 10 to minus 2. 1 minus 10 to minus 2. Let me display it nicely, which is 0.99. Ooh, shouldn't be doing that. Let's get that text format cell. Let's see if it works now. No, it didn't work. Oh, what a shame. Let's try that. 1 minus 10 to minus 2. No, it should work now. Superscript. Yeah, now it worked. Sometimes Excel doesn't do what you ask him to do. Okay, here you go. Which is 0.99, right? The next one is 0.999, it's 10 to minus 3, right? Next is going to be 10 to minus 4, right? 10 to minus 5, 10 to minus 6. I go all the way up to 10 to minus 7. Yeah, I go all the way up to 10 to minus 7 here. And notice that I have this other horizontal row here, but it's alpha, right? Alpha is the complement of CL. Those are all statistical parameters. See, alpha is 1 minus 0.95. Here, this alpha here is 1 minus 0.99, and so on. Some people are more familiar with alpha than with CL. Okay, I like CL better. I like CL better because it gives you a measure of how close your mathematical model is to your data points. Okay, and then you have this huge table right here. What is those numbers are all about? I'm going to explain that to you. Okay, so here you go. 10, let me finish my table, right? 10 to minus 5, 10 to minus 6, 10 to minus 7. Remember that I told you that CL has anywhere between has a value anywhere between 0 and 1, right? But of course, I cannot display all those values here in this table. It would be very difficult to do that. It'd be very difficult to build a table that display all the values of CL, all possible values of CL. But you should know that, here you go, 1, 2, 3. To the extreme left, you're going to have a CL of 0 here. Make sense? Okay, so here you go. And I'm going to likewise, all the way down to the right, you should have a value of 1 here. Okay. That's not shown in my table, but you should know that by heart. Okay. Notice that I don't have 0 in my table. I don't have 1 in my table. That's something that you should know, that to the extreme left you have 0, to the extreme right you have the ultimate value of CL, that's 1, which is 100%. Okay, and then everything else here in between. What do we have? Everything else here in between. I'm going to, here you go. I'm going to put it very large here. You have all sorts of values. Here you go. Which are them? They are the critical values of R squared. So we have N here, we have CL here, and the body of the table, you have R squared, your R squared value. From the R squared and N, you are going to find out what the value of CL here in this table. Okay. So let's write it down here. Lab notes. Throughout the semester, you will be using this CL table. You will use it to find CL given N and R squared. Okay. That's how we're gonna do that. Given n and r square, find CL. In other words, right? In other words, given n and r square, find CL. Here you go. In other words, given n and r square, comma, find CL. So let's come up with some exercises, some quick exercises. I'm going to give an example. And later on, we'll do a quiz. Here you go, find CL. I'm going to start with the simplest possible exercise you're going to see out there. Okay. Okay, given n equal to 6 and example, right? Example, we're going to do that together. Given n equal to 6 and r square equal to 0.84 1255, find CL. Solution. Oops, this one here. So think about that, how you're going to use this table to find CL. I'm going to do something else here. Here you go. I didn't do that. Let me do that. Right now, I'm going to write down r square here. That's the genetic explanation of the table that you see in there. Superscript, and I'm going to increase the size of this guy as large as I can. Can you picture that? All right. Now I'm going to make it look nice. I'm going to shrink a little bit more. That's like I said, that is a explanation of what that table is all about. N is in the vertical, number of data points in the vertical, CL is in the horizontal, and R square in the body of the table. Okay. If you get lost in that table, always refer to this table. Hey, don't forget n can go all the way down to infinity, right? Let me do something else here. I'm going to do something else better, okay? Yeah, here it's going to be 0. Oh, too big, too big. Why is it? Okay, let's get that. I'm going to make it better, this table. Here you go. When CL is 0, R squared is going to be 0 as well, right? And then when CL is 1, R squared is going to be 1 as well. Let's, and now I can go superscript. Let's see, 70. Now we have a better way of displaying this table. We still have R square here, right? So when r squared is equal to 0, CL is going to be equal to 0. When r squared is exactly equal to 1, CL is going to be automatically equal to 1. Doesn't matter what's the value of n. Okay. So did you manage to do that little example? Treat it as an exercise. I'm not going to. You have 6. Yeah. Don't forget. Now, writing here, were you able to do that? 9:48. We are about to have our break. Okay. So, going back to the table, right? N equal to 6. What should you do? You should look for r squares that are here along this horizontal line on the table. But and I gave you also the value of r squared, which is 8.841255, right? What does it mean? Okay, it means that my CL is going to be along this vertical column. Okay, 841255 for n equal to 6 correspond to a CL that's equal to 0.99 or 99%. Okay? I'm gonna do that in the spreadsheet here. So we're gonna do a spreadsheet on the side. So here you go. I'm not gonna do every number, okay? Just some of that. 3, 4, 5, 6, 7, 8, 9, 10, right? Otherwise it's too much work. Here you go. Unnecessary too. And then we have CL, right? CL on my table is 0.95, you know, 0.10, 1 minus 10 to minus 2, 1 minus 10 to minus 3, and so on, right? Here you go. Right in here. And then somewhere around here, let's go back to our table. I have 0.84122. 0.84122. Oh, wait a minute. 0.84125, right? Somewhere around here. And then you have all the other numbers in around this value, right? So what's the CL for this case? Okay, the CL for this case. Well, you go table, table. You go along the horizontal line for n equal to 6, and you look for 0.84122 in the table. You find the CL by going upwards in the vertical direction until you intercept the CL row. Okay, that's how you find the CL. 9:51. Let's do one more example here so you can get good at that. You'll be using this table throughout the whole semester. Okay, one more. Given that CL, you know, looking at the table, we find that CL is equal to 0.99. Okay. So let's take a look at another one. What about n equal to 7? Okay, and I'm going to give you another value for r squared. You know, 0.76. Let's see here. 4796. Find CL. Okay, what's gonna be this CL here? Press that on your side. Yeah. Someone said, yeah, 0.99, right? Yeah. Anybody else? Yeah, so here you go. Now notice that 0.76 for 796, right? For 796 is just below this other one, right? So if we move upwards, you're going to find the same CL. Did you notice the difference between those two? You know, we have the same CL, but we have different ends, right? One is greater than the other. Did you notice what's happening here? As you increase the number of data points, okay, you do not have to get as high of an R square value, right? Take a look what's happening here in this column. Your R square here is 0.999, right? Then it decreased to 0.98, decreased to 0.91, decreased to 0.84, and so on. Do you see what's happening here? The more data points you collect, the less stringent your R square has to be to get the same CL. Okay? So here you go. We can write that down here. Note CL, you go. That's the answer here. Note C from the table for CL that the higher the number of data points n, comma, the less stringent is your requirement for R squared. Yeah, and by the way, that happens throughout the whole table. That happens throughout the whole table. Whether it's for CL 90.99, whether it's for CL 0.999, okay, take a look here. Those numbers are decreasing consistently throughout the whole table, going downwards. Okay, so when you increase the number of data points, in a way it's easier for the R square, right? To find the same confidence level. So get familiar with that. And here's the table again. Okay. And let me take attendance. It's time for 56 right now. Any questions about that? Before you move forward, I want to take attendance now and go for our break. We're doing that for almost 1 hour. Attendance right in here. Today is lab. Oops, this one right in here. The 14th. If you do not have a group, let me know. Okay, some of you still don't have a group. Neil, Anino, are you there? Let's see. I don't see Neil Anino here. In Maria Arguelles. Are you there, Maria? Doesn't look like she is. Lucy? Lucy doesn't look like she's here. Sana, are you there, Sana? Okay, don't hear from Sana. Julissa Molina. I don't see Julissa either. Samuel Sanchez. Samuel Sanchez. I don't see Samuel here either. Vanessa Bonilla.
Here.
Okay, thank you, Vanessa. McKean Curto.
I'm here.
Good, thank you. Fisher.
I'm here.
Okay, thank you. Next is Blessing. Blessing, are you there, Blessing? Okay, I'm gonna put a C Blessing in the list. I'm gonna put a star here. He might be away. She might be away from the computer. Janet Garcia.
I'm here.
Okay, thank you. Wendy Hernandez.
I'm here, Professor.
Thank you. Ryan On.
Blessings here. My mic wasn't working.
Okay. Let's see. Blessing is here, right?
Yeah, my mic wasn't
Okay.
working.
Thank you. So thank you. And Ryan, is Ryan there? Ryan's not there. Okay. Okay, 0. And Mia Villalobos.
I'm here, Professor.
Thank you. So,
Oh, Professor?
yeah.
Ryan Ong had said that he was getting x-rays for his shoulders, so he might show up later in the lab.
Okay. Okay. Raymond Garcia, are you there? Raymond, I see Raymond here in the list. Oh, yeah. Okay, good. You send a message through the chat. Thank you, Raymond. Donovan, are you there?
I'm here,
Donovan?
Professor. I'm
Thank
here.
you. Thank you. Joshua Jimenez.
I'm here, Professor.
Okay. Next, Luis.
I'm here, Professor.
Okay. You have a group, right? Yep. You do have a
Yes,
group.
I do, Professor.
Okay, good. Lily.
Yes, I'm here.
Thank
Also,
you.
also Professor Michael, he put on the chat that he's here, but his microphone's not working, but he's in class.
Okay, Michael Hasid. Okay, I see him. Thank you. Okay, please tell him to send me a message to the chat. Let me see. You send a message to chat. Okay, good. Thank you. Either microphone or chat works for me. Sometimes I don't see the chat, right? Message. Daisy Mariscal.
Hi, Professor. I'm here.
Okay, thank you. Donia.
Here.
Good. Next is Ana Lopez.
Here.
Thank you. Next. Mary Okeki.
Good morning, Professor. I'm here.
Okay, thank you. Next is Jennifer Perez.
Here.
Elika Vafay.
Here.
Thank you. Bethany.
I'm here.
Next, Arthur Pacheco.
Here.
Okay, Brianna Valencia.
Here.
Pedro Ruiz.
Here.
Thank you. Basilio Lopez. Basilio, let's see here. Okay, thank you, Basilio. Next is Vahad. Vahag, let's see. Vahag. Yeah, I don't see Vahag here. Oh no, I see. Okay, we'll put a star. Okay, Vahag. If your microphone is not working, just send me a chat message, please. Alejandra.
I'm here.
Thank you. Next is Amarilis. I don't hear from Amarilis.
Here.
Okay, Amarilis. Okay, good. Thank you. Next, Justena.
Here, Professor.
Okay, Yesenia. Okay, one more. Lebilud.
I'm here.
Thank you. Lydia. Rosa
Here.
Buenrostro. One more. Jade Izquierda.
Here.
And Ashley Diaz.
Here.
Erika Fajardo.
I'm here.
Okay, so who was not called? Let's see how many I have here. 33. Okay. Vahag, are you there, Vahag? Okay, so I don't hear from Vahag, and let's go for our break. And it is, we're gonna have our break until 10:20 a.m. Okay, so see you in 15 minutes. Again. Okay, so what's the next step here? Okay, here is the special case in which, you know, those two examples. Here you go. These two examples, okay? Examples are special cases in which I provided you with the critical value of R square, okay? So the values that I provide to you was exactly the critical values, was exactly those two values here, 0.841255, 0.764796, okay? In real life, when we perform the experiment, we don't get exactly those values. And then, because of that, you have to learn how to report the proper CL for those values that are there in between, right? In real life, you don't get the exact critical values. Instead, the exact critical values of, right? The critical values of R square. Instead, you know, you get an R square somewhere in between.
Professor, I
Somewhere
think
in
you're sharing
between.
your screen.
Oh yeah, I gotta share the screen. Thank you. Let's get that here. So here goes screen. Now I have it, right?
Yes.
Good. So again, these two examples, right, that we did right now are simple examples that I provided the exact critical value of R squared. For that critical value, you have that 99%, right? For those two specific critical values, you have that 99%. In real life, you don't get exact critical values. In real life, you get somewhere in between. Okay, so the question is how you're going to report that in the lab, right? In real life, you're going to get somewhere between 0.8412 and 0.9048. Okay, so the question is how you're going to report the CL. Okay, the way we do here in my lab is in the following way. You report the bounds of the CL. If your R square falls anywhere between those two critical values, for instance, what you should do? You should say that your CL is greater than 0.99 and less than 0.999. Okay, that's what you should do in the lab reports. Okay, let's do an example. Let's do an example. And now we are going to use that data from you got right here. Okay, so here you go. Given, right, R squared equal to 0.9807, right? Given R is, oh, didn't copy it. R squared equal to 0.9807. And n equal to, don't forget, you told me what was the value of n, right? I'm gonna just put a question mark here for the graph, right? For the graph we worked before. Find the lower and upper bounds of CL using the table provided. Okay, so here we go, another example. Okay, now I want, let's do that. The lower and upper bounds. We can even do a quiz, right? On that. Let's do a quiz on that, right? So here you go. I'm going to give you some examples here. Option A. You know, lower bound 0.95, upper bound 0.99. Right, lower bound 0, upper bound 0.95. Let's see here, 0.99 and lower bound 0.999, right? Comes to a point that becomes very difficult to keep on track of the nines there, right? So I start writing in powers of 10. Here you go. Powers of 10, here you go. What are other options? 10 to minus 3, 10 to minus 4, 10 to minus 4, 10 to minus 5, 10 to minus 5. We have a bunch of options here, right? For you to choose from. 10 to minus 6, 10 to minus 7. And then the last one, you know, 10 to minus 7. 10, yeah, that shouldn't be 10 to minus 8, should be 1, right? Because my table doesn't go. So you have all those options here. Let me, here you go, this one here, right? And in this meantime, I'm going to work there on the quiz. Think about that. You should know how to do that now. It's going to be quiz number 7, right? Notes. Yeah. Start working there. You already have the enunciate. I'm going to do courses. Physics. This one here. Quizzes. Quiz 7. Okay. I'm gonna make it do today. Let's see. Well, let me prepare the question
Professor,
first.
a
Yeah.
quick question. For the
Uh-huh.
quiz that people got it right, but it came wrong, is it gonna get fixed? Did
Are you talking about quiz number 3?
yeah, did Canvas fix it yet?
Yeah, I didn't fix it yet. Yeah, I'm trying to get hold of those guys to fix it. Okay, in the past I managed to fix it, but let me prepare this question first, and then I will get back to you. Okay, so here you go. Question number 7.
Professor, I had a quick question.
Yeah.
Are we supposed to answer the example that you have up right now?
Yeah.
And then do we just send it to you in a private chat or?
No. You're going to do on Canvas, okay? You're going to do on Canvas. I'm preparing the
This is
question
like
right now.
a quiz on Canvas.
Yeah. There's gonna be a quiz on Canvas. Hang in there.
Okay.
I'm preparing that in real time. F and G. So I will go all the way up to I. F, G. So now you have plenty of time to think about that, right? And let's see what is the
Professor, I don't know if it's just my computer, but there's nothing showing up on Canvas for a quiz.
bear with me, I didn't finish yet.
Oh, okay.
I'm
Sorry.
preparing right now. Okay, so let me save that. Good, and that's gonna be number 7, okay? And I have to publish it. Is unpublished. And let me put here the date. That's 10:32 right now. I'm gonna give you 2 minutes for 2 minutes, and you had much more than that, of course, right? So let me see, 32 right now available until 10:40. Okay, and now I'm gonna publish. Some of you are gonna have a little bit more of time. And let me moderate this quiz here. Okay, now you should have it available there. You have 2 minutes to answer the question.
It's quiz 7, correct?
Yeah, quiz 7.
Okay.
Rules. Extra temps.
Mine's blank. It's not showing
Really?
me. Yeah.
Is blank for everybody?
Yes, Professor.
Yes,
Mine's blank also.
Okay, so maybe I didn't save it. Is it possible I didn't save it? Let me check here. Hang in there, hang in there.
The time is already reading though, Professor.
Yeah, I will fix that. I'll fix that.
Thank you.
Let me see. Is it blank? Edit. Let's see what's going on here. Question 7. Okay, let's see here. Yeah, is published. New question. Oh, you're right, it's blank. Why is that? Yeah, okay, so let's let's do that again. Strange. Okay, question 7. Looks like I didn't save it. Question 8. Question B. Question C. D. Question E. Okay, so let me. Okay, let's see if it's there now. Update. Points. Yeah, it didn't. Yeah, something is going odd here. Let me see. Let me see. He did. Okay, let me unpublish it. Okay, I'll have to start from scratch. Okay. No, well, you know, let's skip this quiz. It's let's skip this quiz. I'll give you the answer. Let's skip that. Okay. And
Okay.
what did you get? Send me that by chat message. I'm not gonna give you any points for that. Okay, and then we do a better quiz later on. Okay, so what you have plenty of time to think about that, right? Go ahead, you know, send me what you think it is, upper and lower bounds. Okay. Anybody else? Did I? Okay, yeah. 7.
Professor, just to
Yeah.
clarify, we're not getting graded on this question, correct?
Yeah, that's right.
Okay.
We're not getting graded on this question. That's right.
All right, thank you.
Just something is happening with Canvas that I cannot get it to work. Okay, so let's see. We have r squared equal to 0.9807. Here you go. Right in here. That's the graph, right? Let me share the screen. Yeah. 9807, right? Don't forget, we have a total of 7 data points, right? Not 6, but 7 data points. This, you count 1, 2, 3, 4, 5, 6, 7, right? So here you go. This one right in here. 7 data points. And now we go to the table, 9807 and n equal to 7, right? N equal to 7 is right in here. 9807 is where? 9807 is between those 2 points, right? Between those 2 points here, those 2 values. So we go upwards and you see that the lower bound is 1 minus 10 to minus 4 and the upper bound is 1 minus 10 to minus 5, okay?
Professor, I have a question.
Yeah.
I think I missed, where did you get the n value from?
Well, look at the graph, right? Here you go. We're using this one as the graph, as the data points to find the CL, right? Okay. So that's what the enunciate was all about. Here you go. Given r squared equal to 0.9807, right? For the graph we worked before, see that? For the graph we worked before. Okay. For the graph we worked before, find the lower and upper bounds of the CL using the table provided. Okay, most of you told me that was this one here, right? 10 to minus 2 and 10 to minus 3. In reality, it's 10 to minus 4 and 10 to minus 5, right? So check why you got it wrong. Maybe it was because of what? Let's see if I can figure out why you folks got 7. Letter D, let's see. So the actual answer is not D, right? The actual answer is 10 to minus 4 and 10 to minus 5. Should be F, right? Okay. Okay. Why did you get that? I wonder why. Let's see. Most of you got
Trying
the
to
D. Do you
remove
understand?
one of these ones. So I just came to confirm the number.
Okay. Yeah, you're breaking up. Would be better if you send me a text message, a chat message. Okay. Why? Let's see. Why is that you got D? Most of
I
you
don't
got.
think that we were looking at our Excel sheets. I think we were just looking at the data table that you gave us for the information. We weren't thinking about the end value from the Excel sheet. We were just looking at the table, if that makes sense.
Yeah, which table were you looking at?
The one that you sent to us through the confidence level table. So we were looking
Yeah,
at
that's right.
between 9807 and so if you did the 10 to the negative 2 and 10 to the negative 3, the end value would be 4. And I think that's kind of where we were looking at. We weren't looking at, you know, we had 7 and 7 from our Excel sheet from before. I think that we thought you were referring to just this table alone.
Okay. Yeah. No, you need the data, right? You need the data, right? You need the data to work with this table. Let's do another one. Let's do another one. Here you go. Let's see. I'm going to go back. Do you see the graph here? You all see the graph, right?
Yes.
Okay, good. So let's tweak a little bit more this data, right? To get a different R square. And let's see, I'm gonna put 0.9. So I'm gonna get a different R square here, 2.5, 3.2, 4.4. Now the R square is going to be lower than before, right? Because the data is more spread out. What about here? This one is going to be okay, here you go. And I'll get this one, you know. Now using this data, right? For R square equal to that and N equal to whatever you have here. Find the bounds of CL, okay? So you always will have to have actual data and the table to work together. Suppose that you perform an experiment, you got this data there, and now find what would be the bounds of your CL. Okay. You're not being graded, you're just practicing it. Okay, so let's see. I got. Don't forget, it's not. It's always 1 minus the power, right? That's a common mistake that students make when they write the lab report. Okay, Fisher. Make sure you write down 1 minus whatever, right? Because if you write that down in the spreadsheet, you're not gonna get the points for your lab report. Yeah, here you go. Thank you. I want to give everybody an opportunity to practice that. I'm going to, let's see, 9759, right? Here you go. I'm going to copy that and paste on the other one. Here you go. to 97759. 0.9759, n is still equal to 7 because I didn't change the number of data points. Find the lower and upper bounds of CL using the table provided. Okay. Note that you are supposed to answer in powers of them. 1 minus something else, right? 1 minus something else. 1 minus the power of 10. Everybody get that? So let's go. 0.9759. Here you go. 7 data points. 0.9759. 0.9759 lies between those two data points. So if you roll down 1 minus 10 to minus 4 and 1 minus 10 to minus 5, you got it right. Okay? Okay, so that's what you folks are going to be doing. Throughout the lab. And 10:45 now, we're going to be here until 12:50, right? Yeah, 12:50, no, 12 o'clock. Yeah, we're going to be here until 12 o'clock. So we have 1 hour and 15 minutes. Let's start the lab now. You know, study this table, try to, get familiar with it, how to use it. Okay, I can start seeing that some of you already understand how to report that. Just make sure when you report the numbers, don't write 10 to minus 4. Don't write 10 to minus 5. Should be 1 minus 10 to minus 4. 1 minus 10 to minus 5, right? Just like it's written down here. It makes a huge difference between this value and this other value here. And so I'm gonna get, let's see here. Oops, stop sharing. Hang in there. 21. What I'm gonna do now, I'm going to upload the data, the raw data for today's experiment. Okay. And I will explain what is the theory behind that so you can understand how to do it. And here you go. It's going to be, what am I doing here? What am I doing here? Let me share the screen again. Here you go. Here you go. What I'm gonna do, I'm gonna upload a spreadsheet for each in each of your group folders. Okay, group 1 has the spreadsheet in there. Notice that how the spreadsheets are labeled. There it's labeled like P37, L01, G01, right? G01 for group. Oh gosh, I gotta do some cleaning here. Okay, let me delete group 1. Just ignore that that spreadsheet here. Remove. Okay, that's not the right data. Let me see. Everybody's here. Okay. Good. 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 I'm just making sure that you have only what you need here in those spreadsheets before I upload them. Okay, this is the other one that we're working on. Okay, so it looks like we have everything in place here. I'm gonna take a last look. Okay. This one. This one, yeah. Everything seems to be in order here. Okay, good. Now I can upload that. Group one, good. Group one, you have your spreadsheet there. If you don't have a group, let me know. If you do not have a lab group, let me know, please. Group three, group four, group five, group six, group seven, group 8, and group 9. Okay. Good group 3. I mislabeled your spreadsheet. Okay, let me label it back again. Rename it. Here you go. Take out this one in case you have already downloaded. Group 3 or spreadsheet. Oh, it's not P37 either. Ah, gosh. It's supposed to be P06 because now it's P06, right? So go ahead, relabel your. Here you go. I uploaded the following spreadsheet to your group folder. P37L01G group number, right? I'm going to put GX here. Okay, 0X, G0X. Okay. So what I want you to do, download this spreadsheet to your hard drive, your computer hard drive. Okay. Rename the spreadsheet, rename it to P06, okay? L01, group 0, whatever group number you are, okay? If you're group 1, you put 01. If you're group 2, you put group 0, G02, okay? And so on. I'm gonna put an X here. We're gonna be working, we are going to work with the data in these spreadsheets. Okay. Spreadsheets. We're going to work with the data in these spreadsheets.
Quick question.
Yeah.
When we work on it, do you want us to download it to our own computer and work on Microsoft Excel, or do you want us to work on the Google Docs Microsoft Excel?
Yeah, download your hard drive. I'll download your hard drive and work with Microsoft with Microsoft Excel in your computer.
Okay, thank you.
Google Sheets is not going to work well with this spreadsheet. And you should be, remember, this is a group activity, right? You should be in contact with your group members while you work on that.
Are we turning in one assignment all as a group, or are we turning individual assignments in?
Yeah, you turn only one per group. Okay, this is a group activity. That's gonna be, it's gonna take. We're running out of time. You're gonna have more time than than I usually give you. Okay, so you don't. The way we're gonna do that, you know, we're gonna work on this spreadsheet today. You don't have to turn. You do not have to turn it. You don't have to turn a lab report yet. Okay. So we're going to work on that today and next week as well. Next week, I will tell you more about the report. So make sure you're in touch with your group members. Okay, here you go. Now, what are we going to do today? Our labs, you know, in this first lab, okay, we usually work with 3 different measuring instruments. Those are instruments that are available out there. The first one everybody's familiar with. Everybody should be familiar with the ruler. Okay? Right? The other instrument is a fancy ruler, and it's called the vernier caliper. It can measure lengths, diameters, lengths, width, and so on, just like the ruler does, but it's a slightly different instrument. I'm gonna illustrate that to you. And the other one is the micrometer. Has anybody worked with a vernier caliper or a micrometer before? Yeah. So just send me a chat message. I want to know if you folks have ever worked with a vernier caliper. A ruler, I'm quite sure everybody worked with. No vernier caliper, no micrometer before. Okay. Micrometer, yeah, okay. Donovan did work with micrometer. That's good. Anybody else? Okay, and there's a proper way of, so what we're going to do, we start with the ruler, okay? Everybody's familiar with the ruler. Is the manual, yeah, the manual. Let's start with the ruler. Let us start with the ruler that everybody is familiar with. So what is this experiment all about? In this experiment, I provide you with 6 different steel spheres. Right? I provide you 6 different steel spheres. And if it were a real experiment, and in a real experiment, and you measured 6 steel spheres of different diameters, and you use each of the above instruments to measure the sphere diameters. Okay, so picture, you know, having a sphere in front of you, you get the ruler and you measure the diameter of the ruler. Okay, so when you go to your spreadsheet, make sure you have the spreadsheet in front of you. Okay, here you go. Here's the spreadsheet of group number 1. Okay, so here you go. You can notice that we have a first table here. Okay, and you have to write down the density of the steel. First thing, you know, let's go here. 1, open the spreadsheet. 2, write down the density of the steel in the cell of the first table. Okay, the cell is, what's the cell? Is K16, see that? just the numerical value. Okay, and write down the numerical value of the density of steel in cell, in the cell K16 of the first table. K16, column K, line 16, right in here. You know, go in the internet, you know, find the density of steel in the internet. Vernier caliper or where can we find it? Yeah, that's right. We are not going to work with a vernier caliper or micrometer. That's right. This is, remember, this is a make-believe experiment, right? So what are you doing here, Fisher? I am already providing you with the data that was measured before, okay? And so I want you to, you know, imagine that you have a steel, a spherical steel, a sphere made of steel in front of you, and you are measuring the diameter of the sphere first with the ruler, and then we worry about the micrometer and the vernier caliper later on. Okay. But the first step is that clear, Fisher? Okay, good. So, you know, so before we go for the diameters, write down the numerical value of the density of steel in the cell K16 of the first table. Find the density of steel in the internet. Let's see how we are doing there. Okay, I want to know from everybody how you're doing. Today is the 14th. Okay, Vanessa, did you get the Excel spreadsheet?
Yes, I did.
Okay, were you able to open it?
Yes.
Okay, and now, you know, you gotta find the density of steel in the internet, okay? Can you do that, please? And write it down. Let's go to group number 2. Group number 2. Let's see. Ryan's not here, right? What about Wendy? Wendy, were you able to open the Excel spreadsheet?
Yes, Professor.
Okay, thank you. Let's see. Group. I'm not gonna call everybody, right? Just one per group. Joshua, were you able to open the Excel spreadsheet?
Yes, Professor. I was able to open it.
Okay. What about the density of steel? Did you find it in the internet?
Currently looking for it right now.
Okay, good. Just type there in Google density of steel, right? And report. Hey, and there's more, right? Report it in kilograms per cubic meter. Note see that I want you to report the density in kilograms per cubic meter, not in grams per cubic centimeter, right? So let me write that down here. Write down, you know, open the spreadsheet, look for the density of steel in the internet and report it in kilograms per cubic meter in cell K what? K16, in cell K16 of your spreadsheet. That's better, right? Let's see who else. Joshua, that's group number 3. Group number 4, Daisy. Were you able to open the Excel spreadsheet?
Yes.
Yes. Okay. Did you find the density of steel already?
Yes, I'm looking at it right now.
Okay.
Right now I just have grams, so I'm converting it into kilograms.
Yeah. Make sure that the kilogram per cubic meter, right?
Yes.
Okay. So next one here, Jennifer Pettis. Your turn.
Yes, I'm here.
Okay. Jennifer, okay, were you able to open the Excel spreadsheet, Jennifer?
Yes, I was.
Okay, and the density of steel, did you find it?
Yes, I found it.
Okay, good. Don't forget kilogram per cubic meter, right? Brianna? Are you there, Brianna?
Yes, I'm here.
Okay, were you able to open the spreadsheet, the Excel
Yes, I
spreadsheet?
was.
Okay, what about the density of steel? Did you find it?
Yeah, I'm looking at it right now.
Okay, good. So just type there in the another one here. Let's see. There's Basilio. Are you there, Basilio? Okay, good. Were you able to open the Excel spreadsheet? Okay, good. What about the density of steel? Did you find it? Okay, good. Don't forget it's kilogram per cubic meter, right? What about Vahag? Are you there, Vahag?
Yes, I'm here.
Okay, were you able to open the spreadsheet?
Yes, I was able to open it.
Okay, what about the density of?
Yes, that too.
Okay, good. So group 8, let's see, Labelud. Were you able to open the spreadsheet, the Excel spreadsheet, Labelud? I don't hear from Labelud. Yeah, she's there. I'm going to put a star here on her attendance. Okay, let's see, Lydia, are you there, Lydia?
Yes, I found the density and I converted it.
Okay, good, thank you. So Erica Fajardo, are you there, Erica?
Yes, I'm here.
Okay, were you able to open the spreadsheet?
Yeah, but I'm not sure how to open it in Excel. I think it's only letting me preview it.
Really? Okay, you have to do you have Excel installed in your computer?
Yeah, I do.
Okay, did you download to your hard drive of your computer, or are you opening from the cloud?
I'm trying to open it from Google Drive.
Yeah, don't do that. Okay, first you have to download your group number 9, right? Let me
Okay.
walk you through.
Mhm.
Your group number 9. So the way you do, go to group number 9 folder,
Mhm.
click, you see my screen, right? Click on the
Yes.
spreadsheet, right click it, and download it.
Okay.
You have to download to your hard drive. It doesn't work
Okay.
in Google Drive. Okay. So here you go. Let's take a look at the density of steel, right? Density of steel. Here you go. In kilograms per cubic meter. See that? Density of steel in kilograms per cubic meter. If you select that, it's anywhere between 7,750 and 8,050. It depends on the steel, on the type of steel. Now, what I want you to do is just to log the numeric value. Don't put the unit there. Do not put the unit there. Okay? The unit is already in your spreadsheet. Here you go. Here's the unit in the spreadsheet. Now, which value do you use? Which value do you use? It's a range of values. Okay, what I tell my students, I suggest them to take the average of those two values. The steel spheres, and why do you have this range of values? It depends on the steel, okay? What people put in the steel is gonna change the density of it. There are all sorts of steels out there, okay? And depending how you manufacture the steel, you are gonna get different density values between those two values. So what I tell my students, look, we do not know what was the steel that our steels are made, so just use the average value of those, two values, okay? So in this case, 7750, we have 300 units between them. We should be 300, the average, the half of 300 is 150. So you should put what, 7,900, right? 7750 plus 8050 divided by 2. Okay? 7750. Here goes. Ooh. Here is a, you can do that in your calculator, but you can also do that in Excel. I'm taking the average of those values. Okay. And it is in a funny format. Here goes. I put that in scientific format. Okay. So when you take that average, you get around 7,900. Okay. You can do that with your calculator. That's your first step.
Professor, when I get out of putting that amount, it gives me 8.E plus 0.3. So can you show me how to get rid of that symbol?
Sure. So let's do that again, right? Let's see here. You get something like that, right?
Yes.
Okay, good. So I put all the numbers in this format. So how do you change this format, okay? Again, you're going to learn not just physics here, you're going to also learn how to work with Excel, right? Excel is a very important tool because, and we use that all the time. I use that all the time in my experiments when I perform experiments, not just school experiments, but also research experiments. Okay, I do research, I plot graphs, I learn something new that nobody else knows, and I use Excel to do that, right? So how do you change the format of the cell, right? It's a fair question, especially for those who have never been exposed to Excel, right? So the way you do it is like that. Select the cell, right-click the cell, and look for format cell. See, you have all those options here, and even more. Oh, gosh, let's do it again. I did something that I was not supposed to do. Here you go. Here you go. Click the cell, right-click the cell. Do you see all the options that you have? Don't get overwhelmed by that. Don't get intimidated by all those choices that you have. What you have to do, you have to change the format of that cell. So look for format cell right in here. Okay? Format cell. Now notice that I selected the scientific format for you folks. Well, I do that on purpose, okay? Because I want you to work on that and learn how Excel works. What do you need to do? You're gonna put that in a different format. You're going to put that in a number format, in a numerical format. Do you see here? There's general, number, currency, accounting, and blah, 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 right? Even date and time, you have those formats here. So you click on number. When you click on number, that 8E plus 0.3 becomes 7,900. Okay? So the question is, what 8E plus 0.3 means? What does it mean? Can anybody answer that? Can anybody tell me what does it mean? 8E plus 0.3. What does it mean? Think about that. I'm going to write down here in my, what does 8.E plus 0.3 mean? Huh? I know, but what is this? I know it's scientific value, but what's the numerical value for that? Right? What's the numerical value for that? Yeah, here you go. That's right. Daisy, right? Yeah, it's just the fancy, it's just the way that Excel, choose to write down 8 times 10 to the third power. That's it. If you see that for the first time, it might seem confusing, but that's what Excel means. Okay? That's what Excel means. This E here means multiply by 10. Okay? Exponent raised to the exponent 3. Okay? That's what it means. You can see all the numbers in my spreadsheet is in this format, right? If you look at the other numbers here, see that? 8E minus 3, 9E minus 3, 1E minus 2, see that? So what you need to do here, for now only here, is to change the format of this number. instead of scientific format, which is powers of 10 format, you write that down, you display that as a number. When you display that as a number, now you see 7,900. So what Excel did, it rounded up, right? Rounded up. Instead of displaying 7,900, it was displaying 8,000 in that scientific format. Okay? Makes sense? 11:15. Okay, so I think we should take a little break, right? We won't be able to finish this lab today, so we will continue with it next time. So let's go for our break first, and then we use our remaining time to do a quick quiz. Okay, so let me see one thing here. Today is, yeah, let's do a quick quiz before we finish, right? We're just starting the experiment. So we're going to extend the experiment into next week. Okay. What section should we work for group lab? Sections, what do you mean by sections? I don't understand your question, Donovan. This you know, remember, this is a lab. It's not in the book, right? It's not in the textbook. But if you purchase, okay, Donovan, you should be working with your group member, right? So let's see here. You are assigned. That's right. That's right. You should be working with your group members. You stay in touch with them. Okay. Assign each member a task. You know, work together. While and I'll be helping you all out along the way. Okay. So here you go. I am going to, let's see. I'm going to get lab 9 here. Lab 8. I'm just updating the schedule of classes. Lab 6, lab 5, lab 4, 3, right? I'm gonna do that 2 here. And no. So here you go. So we did CL, we still didn't do significant figures, okay? We are going to do significant figures next time. Let's see. Just to update, I'm going to, this is gonna be version 4. Here you go. I will upload this new version of the syllabus back to the folder. Okay, and it is, let's see. Good, it is 11:20 right now. Let's gonna take our break, and then when we return, we do a quiz again. Break till 11:35 a.m. When we return, we will have a quiz. We'll continue this experiment, right? Next week, right? So I see you in 15 minutes. Okay, I'm back here. And we are going to have a quiz now. Okay, I prepared 2 quizzes for you, 2 questions for you. It's 11:35 right now. The questions have the question this time is 2 minutes long. Okay, so let's do it. Let's do that. Here you go. I have. Let's take a look here at the quiz 7 and 8. See that they're due 11:45, 11:50, right? And let's quiz 7, quiz 8. Let me display. You have 2 minutes to do that, right? If you're a special student, I have already added additional time there for you. So you have a little bit more of time than the other students. And let's start with quiz number 7. Am I sharing the screen? Not yet, right?
I just got a grade
Yeah,
for
here you go.
quiz 7 that says it's 0 out of 0.
0 out of 0. Let me
Yeah.
see here.
I didn't take quiz 7. Well, before I opened it and there was nothing there.
Yeah,
So-
maybe. Yeah, now you should have something in there, right?
Okay.
I delete that previous quiz. Let's hope I didn't get into trouble with that quiz 7. I think yeah, that's right. You have 0 out of 0 because you didn't start it yet. Yeah, that's what it is, right? So here you go, quiz 7 and quiz 8, right? So let's see. Do available from 11:30, right? I didn't show the question yet. Here you go. That's the question for quiz number 7. N equal to 6, R squared equal to 9.967. Find the lower and upper bounds of CL using the table that I provided you. Okay. Remember, don't open the quiz until I display the enunciate of the question, right? Don't open the quiz until I display the enunciate of the question. Let me moderate the quiz here and see how you're all doing.
I need to see the
Oh yeah, that's right. You need to
please.
see that, right? Let me go back there. Here you go. I'm gonna do even better. I'm going to freeze the sharing in this screen. Here you go. And now you should be able to see all the time, right? If you don't see the enunciate, let me know. Do you still see the enunciate of the quiz of the question 7?
No, it changed again.
Change it, really? Oh my, okay. So let me give you a little bit of time for everybody, okay? Yeah, I think, let's see here. It's a matter of navigating it. Let's see. That's the one. Okay, now shouldn't be a problem. I'm gonna switch screen again. No, leave like that. Leave like that. I'm getting into trouble too much. Okay.
Professor,
Yeah.
when I clicked start on the quiz, it only gave me 1 minute to answer the.
Yeah. So let me see.
Mine
Let me
is
give you
already
another.
timed out, Professor.
Yeah, let me give you another attempt for everybody since we lost so much time. Let's see how we can do that. Let's see here. quiz number 7, right? Can let's see. Attempt minutes. Allow multiple attempts. Okay. Okay, I'm gonna give you an additional attempt to everybody, okay? And I'm also gonna change the due date, the due time. Yeah, okay. So I don't need to change that. Here you go. Now everybody should have an additional attempt. And Canvas will keep the highest grade. One, yeah, some of you have done twice. Okay, if you need a second attempt, okay, you can have a second attempt. If you don't need it, you don't. Now we're running out of time, right, for the other quiz. To 11:50. Okay, let's go for quiz number 8. Let me give a little bit more of time for quiz number 8. Remember, don't start the quiz until you see the enunciate of the question. Okay, 50. I'm gonna put 11:55 here. Okay. Now, 2 more minutes before everybody finish the quiz 7?
Yes, Professor.
Yeah. Okay, so we have 2 more minutes, a little bit less than 2 minutes. Let's wait 2 minutes and then I will display the question for quiz number 8. And just like before, you're gonna have 2 minutes to do it. One more minute to go. Okay, so I'm gonna display the question. Here you go. What are the 3 instruments we use, right, in the measurement lab to measure the diameter of the steel sphere, okay, of the steel spheres? So that's what we started today. Okay, we want to measure the diameter of the spheres. What were the 3 instruments that I mentioned that to you? And by the way, they are written down there in the spreadsheet. Only 4 options here. Yeah, good. It's frozen. Quiz number 8. There is still some students doing quiz number 8. Let's see how is quiz number 7 here.
Professor, is this the last quiz for today?
Yeah, that's gonna be the last quiz for today. What? 11:47 now. Yeah, we can. If you're done with the quiz, you can leave. And if you want to take advantage of the time remaining to ask me any questions, I'll be here until 12 noon.
Professor, so I was the one that asked about the 9th edition. When would you know whenever I can download the 9th edition so I don't have to purchase the Wiley Plus?
I do not know. I really do not know where you can download it. You can use, by the way, you can use any book, any physics book at at the trigonometry level that's available out there. Okay, so it's that's I really do not know, but we if you want to talk to me about that, you can come up during my office hours. And you can also, take advantage of the notes that I am preparing and posting there in the Google Drive. Okay, you can also take, but I'm quite sure that there are plenty of books available out there, provided you choose one that's trigonometry level. Okay.
I have a question.
Yeah.
Are the exams going to be a similar format where we're reading a Word document and then putting the answers in, or are they actually going to be on Canvas?
The exams are going to be on Canvas.
Okay.
The full question is going to be on Canvas. Only the quizzes I'm typing here in my document.
Okay.
Okay.
Professor, so just to be reconfirmed, our exams, they start by 8 a.m.
Yeah, I'm sure. I'm sorry, but they're breaking up. I don't understand what did you say.
I know that. Sorry. I mean our exams. You said they will start by 8 a.m. in the morning.
The exam?
Yes.
Yeah, you're talking about the final exam?
Yes, and the other exams that we have in the semester.
Okay, the partial exams are going to be 8:50, right? During the regular class time.
For regular class time?
Yeah, 8:50 to 10:50. The final exam, the college is scheduled at 8 o'clock, right? You see that?
Okay.
Yeah,
Yes.
the final exam I don't have any control over. And the final exam, the college is scheduled at 8 o'clock. So there's
Okay.
nothing much I can do about that, okay? But the partial exam is gonna be 8:50. Yeah, the partial exam is gonna be 8:50 during the regular class time.
Okay, 8:50 to what time? 10:50?
Yeah, 2 hours.
Okay. Thank you.
8:50, 10:50. Mhm.
Professor, just to clarify, we do have a lab report due next Wednesday, correct?
No, no.
We don't.
We
Okay.
don't. We don't.
So nothing-
We didn't finish the lab yet. We didn't finish the
Okay, so
lab
then
yet.
for this week, we don't need to do any work for lab, just lecture,
No.
like studying.
No, just review, just review those videos that I have on my YouTube,
Okay,
especially, those ones that are labeled P37 Lab 1. So you become familiar to what we are going to do, okay?
right, thank you. And then,
Mm.
oh, sorry, go ahead.
Yeah,